Okay, welcome back once again to all my dear students. Yesterday we had discussed about the second law of thermodynamics. In that we are going to discuss about the two different topics in which we had discussed. First one, that is the entropy, change in entropy. What is entropy? That is the randomness, right? Means if we discuss about the solid, liquid and gas, then in the gaseous all the particles are away from each other, so we can say that the entropy will be more. All that topic which we had discussed yesterday. Now today we are going to discuss about the free energy and second law of thermodynamics. So let us start about the free energy and second law of thermodynamics. Free energy and second law of thermodynamics. Thermodynamics. Understand? Now, what is free energy? To know whether the chemical reaction will be occur on its own or not, it can be decided on the basis of determination of entropy on both system and surrounding. अगर आपको ये फाइंड आउट करना है कि ये केमिकल रिएक्शन है अपने आप हो रही है कि अपने आप नहीं हो रही, तो आपको दोनों का सिस्टम और सराउंडिंग दोनों का एंट्रोपी, व्हाटएवर द चेंज अकर इन द एंट्रोपी इन सिस्टम एंड सराउंडिंग, यू हैव टू डिटरमाइन, राइट? सो लेट अस राइट डाउन फर्स्ट ऑफ ऑल टू नो whether the chemical reaction occur on its own, right, or not, can be decided or not can be decided on the basis of determination of what? Entropy of both system and surrounding. Entropy of both system and surrounding. Entropy of both system and surrounding. Understand? Now, the free energy is such a state function that in determining whether the reaction will occur on its own or not, only the change that is of free energy of system to be found out. एंट्रोपी में यहाँ पे क्या था कि एंट्रोपी में हमको दोनों फाइंड आउट करना पड़ेगा कि एंट्रोपी ऑफ सिस्टम एंड सराउंडिंग, बट हियर इन द फ्री एनर्जी यू हैव टू फाइंड आउट ओनली the change in the system of the free energy, so that you can determine that whether the reaction will be occur on its own or not. So write down the next point, that free energy is such a state function, right, that in determining what? Whether reaction will occur on its own or not. Whether reaction will occur on its own or not, right? Only change in free energy of system is to be found out. Only change in free energy of system, free energy of system to be found out. Understand? Now let us see the relation of this state function free energy with the enthalpy of the system and entropy of the system. Relation of the state function of this state function, right? Free energy with free energy G, with entropy and enthalpy with enthalpy H of the system of the system, and we can say entropy S of the system, and entropy S of the system. Understand? So I can write down the relationship that G equals to H minus T into S. Right? Now, but if the state of the system changes at a constant temperature, there are changes in the value of all the three state functions. If the state of the system changes at the state of system changes at constant temperature, right? Constant temperature, there are changes in value of all the three. There are changes in value of all the three state function, right? State function. So if there is a change, so I can write down here change in free energy, that is equals to change in enthalpy minus temperature is constant, change in entropy. Understand? So all these things you have to know, right? Next point, we can also say that here delta G for the reaction occurring on its own or spontaneous, the value of delta G is negative. Delta G is negative, then reaction occur on its own because there is a decrease in the free energy of all the reaction in the system, because there is decrease in the free energy. There is a decrease in the free energy, right? There is a decrease in the free energy of all the reaction in the system, of all the reaction in the system, right? Second point, delta G is positive. Delta G is positive, then the reaction will not occur on its own. Then reaction will not occur on its own, right? Is it clear? And if delta G becomes 0, delta G becomes 0, then we can say the reaction is equilibrium. Then the reaction is at equilibrium. Understand? Is it clear? So all these things you have to know. And the most important thing, that the Gibbs free G, that is a symbol and it is indicated by Gibbs free energy, right? And it is a state function and which have extensive properties. It will have the extensive properties. So, and the most important thing, that the absolute value of Gibbs free energy is not possible. So you have to find out what the change in the Gibbs free energy. Understand? So all these things you have to know. This is the most important thing, that the relation between the enthalpy, Gibbs free energy and entropy. Okay, note down. चलो अब नेक्स्ट देखते हैं स्टैंडर्ड फ्री एनर्जी, स्टैंडर्ड फ्री एनर्जी. Now let us see the value of all the element in the standard state are accepted as a 0, right? First point, the value of all elements in their standard state, in their standard state, are accepted as a zero, are accepted as a zero, right? For example, the value of what? That change in free energy, change in free energy in direct reaction, when in direct reaction, when 1 mole compound is produced from 1 mole compound is produced from what? Its element and standard state, its element and standard what? State will be equal to the value of change in standard free energy, to the value of change in standard free energy, for the formation of compound, or of the formation of compound, of formation of the compound, right? Okay, now हम standard किसको बोलते हैं? ये standard means whenever any chemical reaction will be take place at a 1 bar pressure and 298 Kelvin temperature, then we can say it is a standard, right? So if you want to find out the standard free energy, then I can write down here delta F G0, that is a standard, right? 0, that is equals to summation delta F G0 what? Product minus summation delta F G0 what? Reactant. Understand? So here I can write down total standard free energy formation of product, total standard free energy, right, of formation of product, of formation of product minus total standard free energy of formation of reactant. Understand? Is it clear? Now if you want to write down the relation, then I can write down delta Gz or delta G, that is equals to, according to the ideal gas equation, you all know that nRT ln what? P2 by P1, right? So I can write down here delta G equals to 2.303 nRT log P2 by P1, right? According to the Boyle's law, you know that P1 V1 equals to P2 V2. So I can write down here P2 by P1 equals to V1 by V2. So put here, you can get what? Delta G equals to 2.303 nRT log V1 by V2. Understand? Is it clear? So all these things you have to know. And V1, that is the initial, and V2, that is the final volume of gas. Understand? V1 is the initial and V2 is the final volume of gas. I can write down here V1 initial volume of gas and V2, that is the final volume of gas. Understand? Note down color. Chalo. Now next point, that is फ्री एनर्जी एंड इक्विलिब्रियम कांस्टेंट. इसका एग्जाम में आएगा. फ्री एनर्जी एंड इक्विलिब्रियम कांस्टेंट. फ्री एनर्जी एंड इक्विलिब्रियम कांस्टेंट. चलो देखते हैं. What is free energy? For chemical reaction occurring at constant temperature and constant pressure, the free energy is related with the equilibrium constant. For the chemical reaction occurring at constant temperature, and constant pressure, free energy is related with equilibrium constant. Then free energy is related with equilibrium constant. Now let us see the relationship. That is the delta F G0, that is equals to what? Minus RT ln K, or I can also write down minus 2.303 RT log K, right? If the system consists of gaseous state, then we can say K equals to what? Kp. And if the homogeneous liquid of reactant and product is formed, if homogeneous liquid of reactant and product is formed, then K equals to Kc. अगर कोई लिक्विड है तो K equals to Kc, अगर कोई गैस है तो K equals to Kp. Why? Because liquid is there, then concentration will be taken, and if gas is there, then you have to take the pressure, right? Now hence if K is greater than 1, अगर K greater than 1, then delta G will be negative, then delta G0, that is a negative. यहां पे देखो K नेगेटिव आएगा, 1 से ज्यादा है, 10 है, तो log 10 का 1, and therefore it will be negative delta G0. So reaction will occur on its own. Right? If K less than 1, delta G0 positive. Reaction will not occur on its own, right? अगर K की वैल्यू कितनी है, 1 से ज्यादा, सॉरी लेस देन 1, right? क्योंकि यहाँ भी 0.1 log 0.1, that will be negative, and negative it will be positive, right? And if K equals to 1, then we can say delta G0, that is equals to 0. क्यों? क्योंकि log 1 का 0, right? And the reaction is at equilibrium state, will be in equilibrium. Understand? So all these things you have to know about the Gibbs free energy and second law of thermodynamics. Note down कर लो. Okay, and last one, that is Gibbs free energy and useful work. चलो, Gibbs free energy and useful work. Different types of work will be there: mechanical work, electrical work, right? It will be understood from the example described, that is a delta G is the tendency a chemical reaction can be occur on its own or not, right? Free energy is there is a relation with the useful work. Now the relation between the free energy and the useful work. Let us see. The change in free energy associated with any process in the value of maximum possible work obtained from the process, right? So first of all, I can write down here the change in free energy, the change in free energy associated with what? Any process in the value of, with any process, right, is the value of, is the what? Value of maximum possible work obtained from the process. Maximum possible work obtained from the process, right? And if you want to write down that mathematical step, then delta G, that is equals to minus W maximum. Is it clear? Negative sign indicate that the reaction will be occur on its own. Negative sign indicate the reaction occur on its own. Understand? Is it clear? So thus in any process can be done in is used work is done, and let us suppose the process which the value of delta G is more negative, then the maximum work can be done by the process. Understand? So these things we have to know. Second one, that is the electrochemical cell. चलो second हम लिखते हैं कि electrochemical cell is in the operation that electrical work done by the cell, right? When electrochemical cell, right, is in operation, then the electrical work done by the cell, the electrical work done by the cell, right? W electrical. Is it clear? Has the, let us suppose if you want to write down the delta G, that is equals to W electrical, right? And it will be negative. Why? Because the reaction can be occur on its own. अगर मैं कोई एग्जांपल लेता हूँ कि अगर ये पेंसिल सेल, ये घड़ियाल में जब हम पेंसिल सेल यूज करते हैं उसमें क्या होता है कि इलेक्ट्रिकल वर्क विल बी डन, that is the chemical energy is converted into the electrical energy and the work should be done on its own. अपने आप ही होता है ना, right? So that's why we can say delta G will be negative. Okay, so some work will be done. So now here I can also write down that W electrical, that is equals to NF E cell. NF E cell. Cell E cell, that is a cell potential. F, that is a Faraday constant. यहाँ पे लिखता हूँ F, that is a Faraday constant, and it will be equals to 96500 coulomb. Understand? Okay. And that is the number of electron, and that is equals to number of electron, right, passing from the external path of cell, passing from external path of cell, and E cell, that is a cell potential, understand? So all these things you have to know, right? And delta G, now यहाँ पे delta G क्या होगा? तो delta G, put this value over here. So delta G, that is equals to minus NFE cell. This equation you have to know. Suppose if the cell potential will be given and if the electron will be given, then charge will be given, then you have to find out the Gibbs free energy. So according to this, some example will be there, right? So you have to know that how to find out that examples with the help of what? Cell potential. Understand? Okay. Now यहाँ पे अब स्टैंडर्ड लेते हैं तो स्टैंडर्ड में क्या होगा कि डेल्टा G0 इक्वल्स टू माइनस NF E0 सेल. क्यों स्टैंडर्ड? स्टैंडर्ड मीन्स व्हाट? That you all know that 298 Kelvin temperature and 1 bar pressure. Any chemical reaction will be take place, then that is called the standard. Understand? So all these things you have to know that how the one form of energy will be converted into the another form, that is a chemical to electrical, that is called the electrochemical cell, right? Okay, so up to here it's enough. Thank you very much.